Welcome to today's presentation on the production of polyethylene. That's what polyethylene is. The production process of polyethylene, the layout units on the company sides, the software needs of a company with a polyethylene plant, and the computer network connectivity and topology of such a company. Now, polyethylene. Polyethylene is a thermoplastic polymer made from ethylene monomers. It is known for its durability, lightweight, and chemical resistance. The major types of polyethylene include LDPE, the high density HDPE, and the LLDPE. Then it's used for packaging, consumer goods, automotive, and medical devices. Polyethylene process. It begins off with a catalyst preparation, which moves on to the ethylene treatment. It then moves into the reactor section. Then it goes to the flash drum and slurry handling. After then, it is filtered and dried. Then the final product is formed. Here is a complex visual diagram showing the production of polyethylene. So it moves from the catalyst preparation into the reactor. Here we have the dryer, we have the flash drum, we have the drones to dry them, we have the wet polymer, we also have the diluents, we have the water treater, and then we have where the polymer also forms. Now here is a more breakdown section by section of the production process of polyethylene. Now at the catalyst preparation, the catalysts used are aluminum alkyl plus titanium compounds. The catalyst used determines the polymer structure and efficiency. Now to the ethylene treatment section, impurities such as sulfur and water are removed via the treatise. It also prevents catalyst deactivation. Now in the reactor section, that's the core of the polymerization. It operates under different pressures which determine the category of polyethylene produced, whether LDPA or HDPA. Also, in the reactor section, the ethylene is converted to polymer chains. Now to the flash drum and slurry handling, it separates polymers from unreacted ethylene. This unreacted ethylene is recycled, reducing waste. Now to the filtration and drying section, impurities and moisture are removed and prepared for pelletization and extrusion. Now after they've been dried and extrusion has been made, the final product is formed, which are shaped into pellets via extrusion or molding. To other units on the company sites, the control room. The control room should be located near the production units and protected by blast-resistant walls. Also, the control room controls and monitors processes whilst operating via SCADA or PLC systems. The raw materials and storage unit. It stores ethylene gas, catalyst, and input chemicals. It is located upwind and isolated and connected to production through secure piping. Now, the company says should also have an administration building where this includes management offices, HR finance, engineering, IT, and meeting rooms. It should be located near the site's entrance. This site should also include a laboratory and quality control unit where raw material handling and testing, in-process sample testing, and final product quality testing should be made. It should be located near the production packaging areas. Also, the company should have a warehouse and logistics yard where finished goods and packaging materials are stored. The company should also have a utility area where steam and compressed air, nitrogen, and power are provided. It is isolated and secure whilst integrated into the site's energy network. Data requisites of the company, the core computer needs of the company, the distributed control system. The distributed control system controls continuous batch production while ensuring environmental and personal safety. It also enables real-time monitoring. The company should also have a human-machine interface. It has a digital operator interface that allows monitoring events, handling and alarms, and device configuration. It should also have programmable logic controllers. It is an industrial computer that receives sensor inputs and sends control signals to actuators. Safety instrument system. It handles emergency shutdowns and maintains safe states during abnormalities. Network infrastructure. It is the hardware and software for connectivity, which includes industrial Ethernet protocols, OPC, Array, Modbus, TCP, IP. Advanced control and optimization systems, model predictive control for reactor optimization, energy management systems, predictive maintenance models, data needs of the company, inventory management systems, laboratory information management systems, CCTV and security monitoring, pressure transmitters, temperature sensors, flow meters, level transmitters, and gas analyzers. Also, the company should have emergency stop buttons, smoke or gas leak detectors, CCTV for monitoring operations, and thermal cameras for detecting what. Also, the company should have a barcode and RFID scanners used for raw material and products tracking. Those devices such as field actuation alarms, HMI alarm displays, horns, and beacon lights, audible alarms for temperature or pressure anomalies should also be available on site. The company computer needs and reasons. So now the feed for the feed preparation. Feed preparation. There must be fluid transmitters, pressure transmitters, and gas analyzers. Also, in the reactor section, there should be thermocouple or resistance temperature detectors, high pressure transmitter, level transmitter, and safety valves for emergency shutdowns. Also, in the separation chamber, there should be level transmitters, pressure and temperature transmitters, and flow meters. Data and pelletizing section, there should be varied thermocouples, vibration sensors, and load cells. At the packaging section, there should be barcode and RFID scanners, load cells, and label printers for clear shipment identification. Now, the software needs of the company: enterprise resource planning, manufacturing execution systems, inventory management software, human resource software, business intelligence and reporting tools, energy and utility monitoring software, which an example of is Energy Cap, which tracks energy usage and carbon emissions for crucial energy intensive. Now, to the computer network connectivity and topology of the company. The company should have a local area network where it connects internal departments and control systems. An advantage is that it enables fast communication, real-time data access, and central database usage. Also, a campus area network is advanced, which connects multiple LANs across a large plant site, uses fiber optics for speed and reliability, as well as facilitates plant-wide coordination and safety integration. Also, star topology is also advised. Star topology connects devices to a central switch or hub. And a benefit of using star topology is that there is easy diagnosing, isolation of faults, and scalable network expansion. Here comes the end of our presentation. This presentation is by Dana Akomia Sakampensa, Faustina Ofwe Amesaki, and Jim Perry Plenum. Thank you.